This is the triangle, lesson 5-6, triangle inequality and Hinge theorem for geometry. And really, there's three goals today. This is a big lesson, so it may take a little longer than usual. So I can determine if three side lengths form a triangle. I can give a range of values for the third side of a triangle when given two of the side lengths. And I can apply the Hinge theorem or its converse to make comparisons in two triangles. So the triangle inequality theorem basically says this: the sum, or if you add any two sides, so the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So what does that look like mathematically? Well, here's a triangle, and I've called it triangle ABC. And I'll draw your attention back to this notation that across from angle A we have side A, across from angle B is side B, and across from angle C is side C. If you add any two of those sides together, like if you add B and C together, it has to be bigger than A. And if you add A and C together, they have to make more than B. And if you add A and B together, they've got to be more than C. Okay? And then this link's just not active. So otherwise I could show you that. You can look that up, and it lets you play around with the side lengths. So here's an example what it means then. So the question you're going to be asked is it possible to form a triangle with these given side lengths if you've got 8, 15, and 17? So I'll just randomly call these A, B, and C, and I'll take A plus B, and I'll see if that's bigger than 17. And then I'll take A plus C and see if that's bigger than 15. And then I'll take B plus C and see if that's bigger than A. Well, 8 plus 15 is 23. Well, that's bigger. So that gets a check. This one's 25. Well, that's bigger than 15, so that gets a check. 15, 17 make 32, which is definitely bigger than A, so that gets a check. Okay? So these three lengths can form a triangle. All right? Now let's look at one that obviously doesn't work. So if you take A plus B, if you take 6 plus 8, is that bigger than 14? Well, I just stop right there because 14 is not bigger than 14. So to give you a visual, what we would have is we would have this segment that is 14 units long. Then we'd have a segment that was about 6 units long attached here, right? And then another segment over here that's 8 units long attached here. And the problem is they just wouldn't be long enough to reach all the way across. In fact, if we were to just lay them flat on line the 14, you would see that 6 extends to about there. And then you would see that the rest of this would be the 8. And they're just long enough to completely cover the third side. So they're the same length together as the 14. So there's no way they could form a triangle. There'd be no angle measure here and here, okay? And if they were even shorter, like 6 and 7, they wouldn't even reach all the way across the 14. Okay, so do we really need to check all three relationships? Which one in particular do we need to check then? First, to see if this is even going to be a triangle. And the answer is you need to make sure that the smallest pair is greater than the large when they're added together, okay? So we're looking for the shortest two sides. Add those together first, see if it's greater than the third side. If so, the answer is going to be yes. They make a triangle, okay? So here's some examples then. Well, I don't know, let's just work this one out together. So I'm just going to take the two smalls. The smallest two measures are 15 and 16. And if I add those, is that greater than 30? Well, they make 31, and so yes, this can form a triangle. But look at the next one. The shorter two sides are 2 and 8. Are they greater than 11 when you add them together? Well, the answer is no. 10 is not greater than 11. So this is a no. And that's the triangle inequality theorem. Okay? Now, what if we said find the range for the measures of the third side of a triangle? So if two sides are 4 and 8, let's say they're the shortest. If they're the shortest, then 4 plus 8 is 12. And that means the third side can't be any greater than what? Okay, well, let's use integer values here, and we'll just say that 11. So it's got to be slightly less than 12, right? So it can be like 11.99999, all right? Now, what if 8 is the greatest value? What if 1 is the greatest? So then we've got 4 plus x has to be greater than 8. What do you add to 4 to make it bigger than 8? Well, 4 plus 5, because 4 plus 4 doesn't work, but 4 plus 5 is greater than 8. So that third side has to be somewhere between 11 and 5. Okay, so the smallest it can be is 5. I can put equal to. Actually, let's just do this. We're going to put greater than 4, right? It's got to be greater than 4, and it's got to be less than 11. Or, excuse me, 12. Okay? So it's got to be greater than 4 than less than 12. Let's try this next one here. So if I've got 5 and 11, let's say 5 plus 11 has to be greater than, 5 plus 11 is 16. So that third side's got to be slightly less than 16. Okay. And then if 11's the greatest side, 5 plus x has to be greater than 11. Well, that would mean 6 would be equal. So my boundaries are 6 and 16. Okay. So I know that third side's got to be a little bit bigger than 6, because 5 plus something like 6.1 would get us bigger than 11, but a little bit less than 16, like 15.9. Okay. So really, the way we can get this number and this number, given these two values, is we can just say we do 5 plus 11, and that's our upper boundary, and we can do 5 or 11 minus 5, and that's our lower boundary. Okay, so like up here in this example, we do 4 plus 8 is 12. So 12 is our upper, and then 8 minus 4 is 4, and that's our lower. So we use 12 and 4 in our inequality here, okay? Because we really can't give the next number what's a little bit larger than 4, 4.1, 4.01, 4.001, 4.0001. So instead of using an equal to bar here, it's just you've got to be greater than 4. And you've got to be less than 12, like 11.99999. Okay? All right, so you guys give these two a try. Looking for a range of measures. So you're going to write a statement like this right here. Okay? See what you get. All right. Well, for the upper, remember we're going to add those two. So 22 and 34 make 56 is our upper range value. And then lower, 34 minus 22 is 12. So somewhere between 12 and 56, this would still be a triangle. So for this one, 4.1 plus 2.7, that's 6.8, right? And then for the lower bound, 4.1 minus 2.7. So what is 4.1 minus 2.7? Someone have that? let's see, 4.1, 2.7 is 1.4 is our lower bound. Oops. I had my marker, my eraser on. There we go. So those are what we're looking for in answers, is this inequality that gives us the range of values for that third side. Okay? So Hinge theorem. So it's a long statement. It's a very long sentence. If you notice, it's just one big sentence. Just continue to add on to. So it starts with two sides of one triangle being congruent to two sides of another triangle. So if you look at the drawing, we're talking about the orange pair of sides are congruent and the blue pair of sides are congruent. So those are the same length. Then they move to the angle between those pairs of congruent sides. So if this angle Z right here is greater than angle C, right, then what must be true about these two sides across from them? If these two sides are equal to those two sides, and then this angle is larger than this angle, then the third side of the first triangle must be longer than the third side of the second triangle. So that tells me that XY must be greater than, let's not put the bar on the top because it would be the value, than AB. Okay? Because the ZX and ZY and CA and CB, they are fixed. They're the same length sides. It's just this one's open wider, which makes this side longer. So it basically just says the larger side is across from the larger angle if you have this condition where that pair of sides is congruent in each of the triangles, okay? So look over here at this one. So the first thing you want to do is you want to make sure that you're satisfying the Hinge theorem. So here's one pair of congruent sides, right? And then notice they share ZX. So ZX is the second pair of congruent sides. Now look at the angles between them. Over here on the right side, the angle measures 55, and on the left side, it measures 51. So I can compare WX with XY. Which one is across from the larger angle? Well, XY. Okay, XY is greater than WX. Now look at the next one. Here, I'll use a highlighter on this. So here's one pair of congruent sides, and then they share this pair of sides. So I've got this angle here and this angle here that I can compare. Well, this angle's across from 3.6, but this angle's only across from 3. So which angle must be bigger? Is it BFC? Yeah, BFC is greater than FCD. So we would say the measure of angle BFC is greater than the measure of angle FCD. Let me try these two. All right. This one's very, very easy to see because we've got a 15 and a 15, they're congruent. Then we got a 12 and a 12, and they're congruent. And we're comparing this side to this side. Well, which one's across from the larger angle? Well, JK is. So JK is greater than MQ. How about this one here? We got a pair of sides that are 8. Then we have this shared pair of sides in the middle. This is the shared pair. So I've got the red and green side in the upper triangle and the red and the green in the lower triangle. And they're asking me to compare these two angles, this angle here with this angle here. Well, which one's across from the larger side? Well, this one on the bottom, which is angle VRT. So the measure of angle VRT is greater than the measure of angle SRT. Okay? It's a couple, 4 more to do there. Stop the video, give them a try. Turn back on when you're done. We'll see how you do. So I've got a 4 and a 5. 4s and 5s. And those angles, comparing these angles right here, well, this one's across from a 3 and this one's across from a 3.2. Well, that means angle C is bigger, so there's my comparison. Here's 6 and 6, and they share this side here. So we're comparing this side to this side. Well, which one's across from the larger angle? Well, 81 km, so km's larger. We got a pair of sides here, pair of sides here. We're comparing these two sides here. Well, this is across from an 80, this is across from a 90, so ST must be greater. Here's my 7 and 7. So I'm comparing this angle to this angle. Which one's across from larger value? 2.3 is larger, so W is larger. Okay. You're going to find a form, 5-6, that I created that's got questions on the triangle inequality and the Hinge theorem.